welcome to my YouTube channel. So for today, I am going to discuss week 3 for our learning competencies or the most essential learning competencies. So this is DepEd Zamboanga Sibugay GIYA. So we have here our GIYA means Guided Integrated Learning Activities for Learners, Mathematics 11 General Mathematics, first quarter, week 3, day 1 to 4. Our objectives, number 1 is determines the intercepts, zeros, asymptotes of rational functions, solves problems involving rational functions, equations, and inequalities. Mail code is M11GM-IC-1, M11GM-IC-3. This is written by Dena Malimbas, Basalim National High School in Zamboanga Sibugay Division. So we have your day 1 activities. So we have the mini lesson. The teacher said that it's time for you to learn something new. It's all about rational functions, particularly on how to determine the intercepts, zeros of the rational function. Are you ready? Look at the concept and first example below. So what do you mean by rational function? A rational function is a function of the form f of x is equal to p of x over g of x, or q of x rather, where p of x and q of x are polynomial functions and q of x is not the zero function. So we have here the intercepts. The intercepts and zeros of rational function. The x-intercept of a rational function is a point that lies on the x-axis. To obtain x-intercept, assume that y equals 0, then solve for x. Hence, ignore the denominator whenever you want to locate the x-intercept, zeros or roots of rational function. The x-intercepts are also the zeros of the rational function. So again, for x-intercept, you just let y equals 0. For the y-intercept of rational function is a point that lies on the y-axis. To obtain y-intercept, assume that x equals 0, then solve for y. The zeros of the rational function are the values of x which make the function 0. The real numbered zeros are also x-intercepts of the function. So we have here example number 1. Find the intercepts and zeros of rational function f of x equals 2 over x plus 4. First, we need to factor the function. The function f of x equals 2 over x plus 4 is already in simplest form. But here, to solve for the x-intercept, the function has no x-intercept since the numerator is a positive value 2 and not equal to 0. Therefore, the function has no roots. So again, when we let y is equal to, so for here, we can have 0 is equal to 2 over x plus 4. So as you can see that the numerator has no variable. When we let 0, so multiplied by x plus 4, the numerator when you multiply to 0, it becomes 0. So therefore, no x-intercept. To find the y-intercept, let x equals 0. Solution, so f of x is equal to 2 over x plus 4. Since our x is equal to 0, you can have f of 0 equals 2 over x. Substitute the value for x which is equal to 0 plus 4. Therefore, 2 over 0 plus 4 is 4. Then reduce to lowest term, it becomes 1/2. Therefore, the y-intercept of the rational function f of x equals 2 over x plus 4 is 1/2, or the ordered pair 0 and 1/2. Do not forget to answer in the simplest form. Simplest form means that the numerator and denominator have no factors in common. Let's now have example number 2. What are the intercepts and zeros of the rational function h of x equals x squared minus x minus 6 all over 3x squared plus x? So remember that the function can be changed into h of x, f of x, or any letter. So first, for our solution, we need to factor this first, the function h of x equals x squared minus x over h of x equals x squared minus x minus 6 all over 3x squared plus x. So we are going to factor out the factors of x squared minus x minus 6 are x minus 3 and x plus 2 all over the factors of 3x squared plus x. So we can have x times quantity 3 plus this is 3x 3x plus 1. So first, we are going to find the x-intercepts for our solution. Equate each factor in the numerator equal to 0 and then solve for x. So only the numerator, factors of numerator solving for x, because when you multiply the denominator to the h of x, which is our 0, y value becomes 0, automatically it becomes 0. So therefore, the numerator x minus 3 equals 0 implies that x equals 3. Because you are going to transpose negative 3 to the other side, it becomes positive 3. The other one, x plus 2 from the given factor equals 0 implies x equals negative 2. Again, when you transpose positive 2, it becomes negative 2. So therefore, the x-intercepts of the rational function h of x equals x squared minus x minus 6 all over 3x squared plus x are 3 and negative 2. Or the ordered pairs 3, 0. 3 is our x-intercept, 0. We let y equals 0. And the other one, negative 2, and the y is 0. And the zeros of the functions are 3 and negative 2 respectively. Let's now have our y-intercept. So to find the y-intercept, let x equals 0. So we have the function h of 0 is equal to x minus 3 times quantity x plus 2 over x times 3. This is 3x plus 1. So substitute the value of x, which is equal to 0. 0 minus 3 times 0 plus 2 over 0 times 3 times 0 plus 1. So this will become 0 minus 3 equals negative 3. 0 plus 2 equals 2. Multiply the 2. Negative 3 times 2, that is negative 6. All over 0 times 4 equals 0. Hence, since the denominator is 0, that is undefined. Therefore, our h of 0 is equal to undefined, or meaning, therefore, the rational function has no y-intercept, since h of 0 is undefined. So there is no y-intercept. Take note, if the rational function is not in the simplest form, we need to factor it first before we will find for the intercepts and zeros of the function. Here's another example for you to understand well how to determine the intercepts and zeros of the function. Let's now have example number 3. Find the intercepts and zeros of the rational function g of x is equal to 3x plus 6 over x squared minus 5x minus 6. So the numerator and denominator of the function have to be factored first. So we have g of x is equal to 3x plus 6 over x squared minus 5x minus 6. So 3 quantity x plus 2, when you factored out, so it becomes 3. Ipagawas ang 3, then we have the quantity x plus 2 all over x squared minus 5x minus 6. You can have x minus 6 times x plus 1. This will be our factors. So to solve for the x-intercept, we evaluate the numerator to 0. So this will become 3x plus 6 equals 0. So 3x equals transpose, it becomes negative 6. Then divide both sides by 3. 3, so cancelled and 3, it becomes x equals negative 6 over 3. That is equal to negative 2. Therefore, x equals negative 2. Or negative 2, 0. Because we let y equals 0. So we have another way to find the x-intercept using the factored form. 3 of x plus 2 So we have another way to find the x-intercept using the factored form. So based on our function, as we can see above, we can have 3x plus 6. The factored form is 3 times quantity x plus 2. So we can have 3 times quantity x plus 2 equals 0. Solving for x, this will become x plus 2 equals 0. So x is equal to negative 2, because when you divide both sides by 3, so we have 3 here, it becomes eliminated, it becomes 1. So the remaining is x plus 2 equals 0. So we have x is negative 2, the ordered pair is negative 2, 0. The same with our first solution for finding the x-intercept. Therefore, the x-intercept of the rational function g of x is equal to 3x plus 6 over x squared minus 5x minus 6 is negative 2, or the ordered pair negative 2, 0. And the series of the function is negative 2. Let's now have to find the y-intercept. So to find the y-intercept, let x equal 0. G of x is equal to 3 quantity x plus 2 over x minus 6 times quantity x plus 1. So when you are going to simplify, you substitute the value of x into 0. So this will become 3 times quantity, x becomes 0 here, plus 2 over 0 minus 6 times 0 plus 1. Again, our x values become 0. Then you have to simplify. 0 plus 2 is 2 over 0 minus 6 is negative 6. 0 plus 1 is positive 1. 3 times 2 equals 6. Negative 6 times 1 is negative 6. Simplify. 6 divided negative 6 is negative 1. Therefore, the y-intercept of the rational function g of x equals 3x plus 6 over 3x squared minus 5x minus 6 is negative 1, or the ordered pair 0, negative 1. Again, our x is 0, then we have our y-intercept is negative 1. You can now solve the guided practice activity. You can answer, fill in the blanks. After the guided activity, you can have independent practice activity. Then we can have evaluation. So let's now have our day 2 activities. Okay, for day 2 activities, the asymptote of rational function. We have the vertical asymptote and the horizontal. So asymptotes are lines that are approached by the graph of the function. Two types of asymptotes. Vertical asymptotes are a vertical line that is obtained by the x values that will make the function undefined. You can find the vertical asymptotes by finding the domain that will cause f of x to become undefined. By definition, let rational function f of x equals p of x over q of x be in lowest terms if f of x approaches to infinity, or f of x approaches to infinity as the x values approach the value of, then the vertical line x equals a is vertical asymptote. The line x equals a is a vertical asymptote of the graph of f if and only if q of a is equal to 0 and p of a is not equal to 0. Finding the vertical asymptotes. Finding the vertical asymptotes. A. Reduce the rational function to lowest terms by cancelling out the common factors in the numerator and denominator. B. Find the values a that will make the denominator of the reduced rational function equal to 0. C. The line x equals a is a vertical asymptote. Then we have horizontal asymptote is an output value that a function approaches as the input goes to positive or negative infinity. This is a horizontal line whose equation is of the form y equals b, in which the curve approaches but does not cross on it. So let rational function f of x equals p of x over q of x be in lowest terms or lowest term where q of x is not equal to 0. If f of x is approaching to b as x approaches to positive negative infinity, then the rational or horizontal line y equals b is the horizontal asymptote. Three cases for horizontal asymptote. Let f of x equals the given polynomial functions or the rational function. If n is lesser than m, or the exponent of the numerator is less than the exponent of the highest degree of the denominator, then the x-axis is the horizontal asymptote or y equals 0. If n equals m for the second case, then the horizontal, if n, the exponent n, is equal to the exponent m, the highest exponents of both numerator and denominator are equal, then the horizontal asymptote is the line y equals a over b. So you just divide, copy the numerical coefficient a over b. Here's 1. Before the x variable, you can have numerical number here, a over b. If n is greater than m, there is no horizontal asymptote. If the exponent n is greater than the exponent m, the degree of the denominator, so there is no horizontal asymptote. Y is equal to a over b, where y is equal to numerator's leading coefficient over denominator's leading coefficient. Let's now have an example. Let's look at the two examples below in finding the asymptotes of rational function. We have example number 1. Find the asymptotes of the rational function f of x equals 2 over x plus 4. So our vertical asymptote reduces the rational function to its lowest term. The function is already in its lowest term, so no need to reduce it. So set denominator to 0 and solve. So to find the vertical asymptote, you just solve the denominator. So x plus 4 set into 0. So transpose x plus 4, positive 4 becomes negative 4. Therefore, x equals negative 4. This tells that the vertical asymptote will be at the value x equals negative 4. Hence, the vertical asymptote is at x equals negative 4. The horizontal asymptote, the degrees in the numerator and denominator are n equals 0 and m equals 1. So that is n less than m. Hence, the horizontal asymptote is the x-axis or y equals 0. Again, the exponent in the given, since we have here 2, there is no x that is x to the 0. The variable is x to 0, meaning the exponent is 0 here. The other one is 1, x, the exponent is 1. Therefore, the case is n less than m. Since the exponent of the numerator is less than the denominator, therefore our horizontal asymptote is automatically equal to 0. So, hence, the horizontal asymptote is the x-axis or y equals 0. Example 2, what are the asymptotes of the rational function h of x equals x squared minus x minus 6 over 3x squared plus x? So automatically, just have vertical asymptote, reduce the rational function its lowest term. So we have here the factors. Then the denominator is x times 3x plus 1 set into 0. So this will become 3x plus 1 equals 0. Here we have our x equals 0. Automatically, the one value is x equals 0. The other one, 3x plus 1 equals 0. Transpose positive 1, it becomes negative 1. So, solving for x, divide both sides by 3. It becomes x equals negative 1/3. This tells that the vertical asymptotes will be at the value x equals 0 and x equals negative 1/3. Therefore, the vertical asymptotes are x equals 0 and negative 1/3. Let's now find horizontal asymptote. Based on the original function, not factored, The degrees of the function, the numerator and denominator, are equal. That is n equals m. So the leading coefficients are a equals 1 and b equals 3. Hence, the horizontal asymptote is y equals 1/3. Again, they have the same exponent for numerator and denominator. As you can see, our numerator has the highest exponent 2, and the denominator, the highest exponent is 2. They are equal. So our case B, second case, you just copy the numerical coefficient of x here, that is 1, and over the denominator, which is 3. Then reduce the lowest term. Since 1/3 is already in the lowest term, therefore that is automatically our horizontal asymptote. The degrees of the function is the highest exponent of the variable in each expression in the numerator and denominator. Here's example number 3. Find the asymptotes of the rational function g of x equals 3x plus 6 over x squared minus 5x minus 6. So we can have our vertical asymptote. Solve immediately the denominator. So you can factor out, that is x minus 6 over x plus 1 times x plus 1. Set the denominator to 0. So that is x minus 6 equals 0. Transpose negative 6, it becomes positive 6. The other one, x plus 1 equals 0, x equals negative 1. Therefore, our vertical asymptotes, we have here x equals 6 and x equals negative 1. For the horizontal asymptote, as you can see that our exponent here, the numerator is 1, the denominator is 2, the highest exponent. So therefore, since n is lesser than m, the line y equals 0. The horizontal asymptote is the line y equals 0. So you can have this practice activity. Then independent practice activity, match the asymptote. Then we have here, fill me up, give me asymptotes. Then you can have your evaluation. Then day 3 activities. So previously we discussed the asymptotes of the rational function. Now we'll focus on how to solve problems involving rational functions, equations, and inequalities. But before that, we will recall the first rational function, equation, and inequalities. So rational function definition is the function of the form f of x equals p of x over q of x, where p of x and q of x are polynomial functions and q of x is not the zero function. The rational equation is an equation with rational functions. Rational expressions are as terms. Rational inequality is an equality that contains the rational expression. So a rational equation is an equation that contains rational expressions. You can have x plus 3 over 2x equals 5. So take note of the symbol equals. That is from the word equation. Mayroon siyang symbol na equals. So 2x over 2x plus 4 equals. Whereas for inequality, it is an equality that contains rational expression. So the symbol is inequality. It could be greater than, less than, or greater than or equal. You can have x plus 1 over 3 minus x greater than 2. Another example for rational is x over x plus 7 is less than negative 3, and x squared minus 4 over x minus 2 is greater than or equal to 0. So a rational equation and inequality can be solved for all x values that satisfy the equation or inequality. Whereas we solve an equation or inequality, we do not solve functions. Procedure for solving rational equations: eliminate denominators by multiplying each term of the equation by the least common denominator. Second, note that eliminating denominators may introduce extraneous solutions. Check the solutions of the transform equations with the original equation. So we can have example number 1. Solve for x in the equation 2 over x minus 3 over 2x equals 1/5. So for our solution, the LCD of all denominators is 10x. Multiply both sides of the equation by 10x and solve the resulting equation. So we can have 10x multiply here you copy 2 over x, the first term, minus the second term, multiply 10x times 3 over 2x equals the equality. Then we have 1/5 times 10x. Then simplify 10x times 2. X here will be eliminated, it becomes 1. So 10 times 2 is 20. Minus, again x can be reduced. X divided x is 1. So 10 divided by 2 is 5. 5 times 3, that is 15. Copy the sign, negative or minus. 20 minus 15 equals 10x times 1/5. 10 can be divided by 5, that is 2. 2 times 1 is 2. Copy the variable x. Then simplify further. 20 minus 15, that is 5, equals, bring down 2x. Solving for x, divide both sides by 2. Divide by 2, it becomes 5 halves. Or transpose, it becomes x equals 5 halves. Since the solution to the equation has 5 halves, or 5 over 2, then substituting x equals 5 halves in the original equation must take this equation true. So you can have the solution. So 2 minus 3, 2x equals 1/5. You can have 2 over 5 halves minus 3 over 2 times 5 halves. Again, x becomes 5 halves equals 1/5. Then this becomes reciprocal. 2 times 2. The 2 here in the denominator of 5 halves multiplied to the numerator 2, it becomes 4/5. Minus 2 here can be cancelled out. 2 divided 2 is 1. So automatically 3 over 5 equals 1/5. 4/5 minus 3/5, since they have the same denominator, subtract the numerator. 4 minus 3 is 1. Therefore 1/5 equals 1/5. The statement is true, or the equation is true. Example number 2, solve for x. X over x plus 2 minus 1 over x minus 2 equals 8 over x squared minus 4. For the solution, factor each denominator in the fraction. So you can have x plus 2. Here, x squared minus 4, the factors x minus 2 and x plus 2. Therefore, the LCD is x minus 2 and x plus 2. Multiply the LCD to both sides of the equation to remove the denominators. So each of the term will be multiplied by x minus 2 times x plus 2. The second term, 1 over x minus 2, will be multiplied to LCD. And the last term, 8 over x minus 2 times x plus 2 multiplied by the LCD. So x plus 2 here will be eliminated. So this will become x minus 2 times x minus x minus 2 here divided by x minus 2. It becomes eliminated, so the remaining is x plus 2 times 1, that is x plus 2, equals, sa denominator here, the LCD can be eliminated also, so the remaining is 8. Simplify further, this will become x times x, that is x squared, minus 2x, then you can have negative x, so this will become x squared here, squared, then you can have 2x minus 2x, because negative 2 times x is negative 2x here. So again, x times x, that is x squared, minus 2 times x is negative 2x, minus x, because we have negative times x, negative x, negative times positive 2, that is negative 2, equals 8. So to simplify, it becomes x squared, negative 2x and negative x is negative 3x. Then we have here negative 2. Since our positive 8 here, transpose or transfer to the left side, it becomes negative 8. So that is why that is negative 10. X squared minus 3x minus 10. Upon reaching this step, we can use strategies for solving polynomial equations. So solving the equation, x squared minus 3x minus 10 equals 0. The factors are x plus 2 and x minus 5 equals 0. So x plus 2 equals 0, transpose x equals negative 2. The other one, x minus 5 equals 0, transpose x equals 5.